With Kotlin 1.3, we finally have a stable library for coroutines. This means that there won't be any breaking changes to their API, and now is also an especially good time to learn how to use them. Coroutines are basically lightweight and much more efficient threads. As a bonus, they are extremely easy to work with once you know the basics. Asynchronous coroutine code looks the same as a classic synchronous code, which we are all used to. You don't need to learn any new programming paradigms in order to use Kotlin's coroutines. Hello, welcome to ResoCoder. In this tutorial you are going to learn quite a bit about coroutines, different ways of launching them, blocking versus non-blocking code, and async await with context, and more. So let's get started. Even though I am demonstrating coroutines on a plain Kotlin project, I will notify you whenever there is something which is Android specific. So after watching this video, you can jump straight to your Android app and implement coroutines without a problem. So I am using IntelliJ. We are gonna start a new project with Gradle and select Kotlin Java to be the language for our project. Hit next. I'm just gonna say coroutines and the same for the artifact ID. And yeah, we should be good to go. Now, because Kotlin 1.3 is not officially out yet, we need to go over to Tools up here, so Tools, then Kotlin, and now configure Kotlin plugin updates, and you will probably have something like stable, and we need to change this stable to be early access preview 1.3. If you are watching this video a bit later than it was recorded, 1.3 will be already out because at this time, it's already a release candidate. As we can see over here, it's 1.3.0 RC, so it's going to be coming out in really short time. But for now, just change it to early access preview if you haven't already. Next up, we want to go over to the build.gradle, and over in dependencies, we need to add this line over here. And you can get the code from the link in the video description, so you don't need to type out all of this. Just click on the link and it will take you to resocoder.com. Coroutines in Kotlin are not a part of the language, but they are rather a library, and this line of Gradle code imports this library over to our project, so Kotlin X Coroutine Core. As you can see in the version, we are using something like 0.3.1 EAP 13. Over time, once the Kotlin 1.3 is not only release candidate, but it's a full version already, this version of Kotlin X Coroutines will jump to 1.0.0. But for now, because we are only using a release candidate of Kotlin, we need to be using this EAP version of Kotlin X Coroutines Core. Over at this link, which is in this comment above the compile, this is the link where you can find the most up-to-date versions of Coroutines library, and this link will obviously be also in the video description. So now let's hit import changes. Alright, now let's start writing code. So let's go over to main and Kotlin. We want to create a new Kotlin file, and let's call it just main. And it's going to have a main function, which looks something like this. Alright, so usually when you write code, you write something like print line, for example, just to keep this simple, and you print out 1. Then you can also print line, so Control D to duplicate it below, and it's going to print 2, and then also 3. And if we were to run this, it would obviously print out 1, 2, 3. This is called synchronous code because it runs one after another, which is called synchronous. But let's say that over here, this middle print line will have some kind of a long-running hard computation to do, and only then it will print 2 once the computation is finished. So let's create that kind of function right now. So it's going to be fun, and we aren't going to really do some crazy calculations. We are just going to delay the execution of the code by using a really nice function called delay. So we're gonna call this function printLine delayed. and it's going to take in a message of type string. And here would be your complex calculation, but for now we just wanna put some delay over here. So in classical threading, that would be thread.sleep. So for example, 1000 milliseconds, and then we would print line with the message which was passed into this function, right? Now, just so we aren't writing everything inside the main function, I'm gonna create a separate function and paste the contents of the main function over there, and its name will be fun example blocking. So then, after watching this tutorial, you can go over to the link in the video description and get all of the code from there for further reference. And let's paste what I just cut from the main function over here, but this print line 2 will not be a simple print line, but print line delayed. And now from the main function, let's call example blocking and let's run our code. So hit this green play button next to the main function. And as you could see down here, at first it prints out 1, then it waits for a second, and then it prints out 2 and 3. And this is using classical threads. But we don't want to be using threads, we want to be using coroutines. So we are going to change this thread.sleep to call delay, and it's gonna delay for 1000 milliseconds as well. And as you can see up top, we have automatically imported Kotlin Coroutines delay. And also we have an error saying that suspend function delay should be called only from a coroutine or another suspend function. So what we need to do is to write suspend before this fun. And what this does is that it makes this function suspending. And this is a really awesome feature of coroutines. They don't block the current thread like the thread.sleep does. So delay is not like thread.sleep, it only suspends this particular suspending function. So if there is some code over here, right? Some code over here, this code runs, then it hits delay, it suspends the execution, the program is still running, everything is not blocked, and once the delay is finished, it will come back to this precise place and it will run whatever the code is below this coroutine call. And obviously you aren't gonna probably use delay in production, but you will have some kind of a really complex calculation, this time for real. And I am going to show you how to put your calculations inside coroutines in just a little bit. Alright, but now we have another error, which is over here, that print line delayed is also a suspend function, just like delay is a suspend function. So we need to either make this function suspend, and we could do that, but now check this out. We have a problem over in main. So even main should be suspend, but we cannot make everything suspend. Something actually has to be non-suspending. For example, this main function will be non-suspending in our case. So how are we going to deal with calling coroutines from some code if not everything can be suspending? Well, we are going to delete this suspend keyword, and we are going to say that this print line delayed should run blocking, right? And now we are going to put this print line delayed over to this block of code which will run blocking. And in the documentation, we can read that runs new coroutine and blocks, in bold, it blocks the current thread interruptibly until its completion. So run blocking is actually really blocking the thread. So it's pretty much simulating the thread.sleep. There are also other options which aren't blocking the current thread, to which we are gonna get in just a little while. But for now, let's stick with run blocking. So run blocking provides us with a coroutine scope. So basically, this means that we can call suspending functions from run blocking block of code. Now, when we are going to run the main function, it will print out 1, right? And then after a second, 2 and 3, just like before, but now we are doing it all through coroutines. There is also a more idiomatic way to write this blocking coroutine code, and that is to put runBlocking to be basically the root of this function. So runBlocking over here, and it's gonna do the same thing as when the runBlocking was just around this print line delayed, but it's just much more nice to look at, and we can test it, and sure, it prints 1, and then after a second it prints 2 and 3. Awesome, now let's make one more example with runBlocking, and I am going to paste that in here. Alright, so over here we have runBlocking, and we have something called dispatchers.default. When we provide a dispatcher to a coroutine, it will switch to a different thread most of the time. But even though this runBlocking block of code over here will be running on a different thread, so not on the main thread but on some kind of another thread, it will still block the main thread because we are using runBlocking. So now let's call this example blocking dispatcher from our main function, and let's run the code. So we have 1 and then 2 and 3. Over here, 1 printed that it's from thread default dispatcher worker 1. Then 2 is also from default dispatcher worker 1, but we had to wait for 1 second between 1 and 2 because 2 is printing delayed, so it only prints something out after 1 second delay. And only after this runBlocking, which was by the way running on a different thread, but it was still blocking the main thread, because only after this runBlocking block of code has run, only then this third line of code, which printed out 3, ran, and it said that it's from a main thread. Alright, now let's create another function, example launch global. So it's also going to have runBlocking as the root. And over here we also want to print 1 from thread at the start of this function, but then we want to use launch function on global scope. So global scope dot launch, and over here in this launch we want to print delayed just like above. So we are gonna paste it in here. And what this launch will do is that it doesn't block the main thread. You will see what that means once we run this code, but for now we want to have another line over here which will say print line 3, just so you can see how this code is executing. And now let's copy the name of this function, let's paste it inside our main function so that it runs, and let's hit run. So we get 1 and then 3, and we don't get 2. So what's up with that? Well, it's not that this print line delayed is not called. It is called, but precisely because it is delayed, the entire program stops before this delayed function could be executed, because it prints 1, then it launches print line delayed, but it's waiting for 1 second, but it after a few nanoseconds it starts printing 3 because launch is not blocking, so it's just continuing the execution of the code, so it prints 3, and then our program thinks, alright, I'm done here, let's quit this. But the program is not done here, it still needs to print the 2, but it doesn't know that it should print 2 because it doesn't know that it should wait. So we need to explicitly tell it to wait for a certain period of time. So let's hit delay, and for example for 3000, so that it's really noticeable. And now when we run our code, it's still going to print out 1, 3, and then 2, and after 3 seconds, it's going to finish executing. So just to recap, this 2 could be now printed out precisely because we are waiting, so we are explicitly blocking the main thread, and because it's blocked, it registers this printing, this delayed printing of our 2, because print line delayed is waiting for 1 second before it prints out the message. Alright, now let's copy this example launch global and paste it below. And I'm going to change its name to be example launch global waiting. And what are we going to wait for? Well, this delay is really ugly and it's not a good practice, because if you have some kind of a variable length of the delay, so when you are not just delaying, but you are actually running some crazy computation inside your function over here, you don't really know how long that calculation will take. On some machines it can take 1 second, and on some machines it can take like 100 milliseconds, right? Because of that, you need to be able to wait just for this launch to finish executing and nothing more. We can do that, so we can wait for this launch to be fully executed by putting the return value of launch inside a job. Right, so val job is equal to this launch, because as we can see over here, it returns a job. And then instead of delay, we can call job.join, and this is something like delay, but it waits for the job to finish and then it quits the program as soon as possible. So now let's copy this and paste it over to main. And I'm going to actually collapse all of these previous functions so that they aren't interfering with us. So now we are joining the job, and when we run the program now, it will still print 1 and 3, then 2, and it immediately stops. It doesn't wait any longer than it really needs to. Alright, so now let's copy even this function and paste it below, and let's collapse the first one. And this one's name will be example launch coroutine scope. So we are not gonna be launching in the global scope, but we are going to launch in a local coroutine scope. As you can see over here, runBlocking provides us with this, which is of type coroutine scope, as you can see over here. So what we can do is to delete this global scope, right? And we are going to launch this on this coroutine scope, not on a global one, but we could also write this dot launch, which is pretty much the same. So we are gonna launch on the local coroutine scope of our runBlocking coroutine. What this will enable us to do is to delete this job.join, because we don't need to join anything anymore, because now that we are running this launch on a local coroutine scope, our program will know that, oh, I should probably wait for that 1 second before stopping the program so that this 2 can be actually printed. So let's copy the name of this function, paste it over to main, and let's run it. And it's gonna do pretty much the same thing as the code before, but now we aren't explicitly waiting for this job to finish. The compiler is spitting out code that does precisely that, but we don't need to do it ourselves. And as you can see, all of these calls are from the main thread. And just like runBlocking can accept a dispatcher, launch can also get a custom dispatcher passed to it. So let's pass it right now. So let's write dispatchers default, right? And now when we run the code, the 2 will be no longer printed from the main thread, but from default dispatcher worker 1. Then there is also IO dispatcher, but it has shared thread pool with the default dispatcher. So even though we are using IO here, it still runs on default dispatcher worker 1, but IO dispatcher is more suited toward IO operations, so disk IO, network IO, because it can rapidly spin up multiple threads. Then we also have another dispatcher, and that is main over here. And unconfined should not be used from your code, as you can see here. Note, use with extreme caution, not for general code. And when people over at Kotlin say something like that, I am respecting them fully, so I'm not going to touch unconfined dispatcher, because if they suggest that it's not for general code, I'm going to trust them. But we have this main dispatcher, and when we run this, it's actually not going to run because over here it says module with main dispatcher is missing. Add dependency with required main dispatcher, for example, Kotlin Coroutines Android. And you can immediately see that this main dispatcher is intended for Android or for some kind of other rich UI framework. As you probably know, over on Android, you can only change the contents of a text view. So for example, text view.text is equal to hey, right? You can only do that from within the main thread, which can operate on UI. You cannot do anything like that from some kind of another thread. So whenever you want to run a coroutine so that you don't get your main thread blocked, but you still want to do something like this, where you are operating with the UI, you want to use dispatchers.main over on Android, and that will enable you to actually operate with UI. So keep that in mind. Over at Android, you should always use dispatchers.main when you want to do something with your UI. But if you don't have Android, Kotlin Coroutines, you cannot use dispatchers.main because it's just not available. And as a bonus, I'm going to show you how you can create your own custom dispatcher. So we can create a new executor service. But we are going to put it inside the dispatcher. So let's first create val custom dispatcher, and it's gonna be equal to executors dot new fixed thread pool. And you can also do something else, so new single thread executor or something like that, but I'm going to use new fixed thread pool over here, and I'm going to have 2 threads, and then let's call as coroutine dispatcher. This is an extension function from our Kotlin Coroutines core library, and it's going to simply turn this executor, which is used for normal threading, and it's going to convert that to a coroutine dispatcher. And now we can use our custom dispatcher inside our launch. So custom dispatcher, and now let's hit run. And now we get 1, 3, and 2. And this time it's not from dispatchers main 1 or something like that. It's from pool 1 because it's our custom new fixed thread pool, right? But as you can see, there is something not all right. The program didn't stop executing. And when I run it once more, you can see that we have this instance, but we have also another instance of the program still running. So what's up with that? Well, it turns out that with a custom dispatcher, the program doesn't exit execution because the custom dispatcher's thread is still running. We need to manually shut down the custom dispatcher's executor to stop the thread. So let's go down here, and we want to write custom dispatcher dot executor, and we want to cast this executor to be an executor service, and then we want to call shutdown on this executor service. Now let's close all of our programs which are currently running, and let's hit run again. And now we get 1, 3, 2, and we also get this process finished with exit code 0. So now we are good to go and not waste system resources. Calling launch returns a job which we can join either explicitly or implicitly when we are using a local coroutine scope. But it doesn't return a value. And most of the time, however, you want your coroutine to return a value and not just some kind of a job. For example, data fetch from the server or the result of a long-running calculation. That's where async and await and also withContext come into play. So let's collapse this function, and we are gonna create a new one called fun example async await. So also runBlocking. Also over at the top, let's create another suspending function, calculate hard things, and it's going to get one start num of type integer, and it's going to return also an integer. And over here we want to delay for 1 millisecond, so also delay one, or not 1 millisecond, but 1 second, so 1000 milliseconds, right? And then we want to return start num times 10, right? So we are returning a value from calculate hard things, but we didn't return anything from print line delayed. Now let's go down to our example async await. And how are we going to get this return value from calculate hard things in a coroutine and then propagate it outside of the coroutine? This is a bit of a problem, but thankfully Kotlin solves that problem for us with async. So we are going to create val deferred one, and it's gonna be equal to async, and then this async block of code will call calculate hard things. And we are gonna pass in 10, and then we could immediately call await. So here await, and it would basically for now block the thread because we are inside runBlocking coroutine. And once this calculate hard things would stop running after 1 second, it would continue with whatever the code is below. But async and await are really well suited for running multiple things concurrently because we want to have also another val deferred. So let's copy it and paste it below. It's going to be deferred 2. And it's going to, oh man, the start num will be 20, right? And then also deferred 3, and the start num will be 30. And if we were to call await, await, and await after each and every async, this block of code would run 3000 milliseconds because calculate hard things runs for a second because we are delaying the execution by 1000 milliseconds. However, because we are using async, we can await all of the results of our async functions at once. So let's do just that. We are going to create val sum, and it's going to sum every single deferred. So deferred 1 dot await plus deferred 2 dot await, and also plus deferred 3 dot await. And then we are going to print line async await result, and that result is equal to our sum, right? And just so that you believe me that this code doesn't run for 3 seconds but for less, I'm going to create val start time over here, and it's gonna be equal to system dot current time millis in milliseconds, right? And then also end time down here. And I'm going to print line saying that time taken to execute this whole function is end time minus start time. So now let's copy the name of this function and let's paste it above in main, and let's run our code now. And we get async await result is 600, but more importantly, the time taken for this whole example async await function is only 1028 milliseconds, which is basically a second. So this means that we are running all of our asyncs concurrently because every calculate hard things call takes 1 second, and they are taking place concurrently at once and not sequentially as they would be if we called await after each and every async immediately, right? So we call await, then so let's check it out, right? So we delete await from our deferreds when we are summing them up, and now when we run our code, it's not going to take only 1028 milliseconds, but it's going to take something like 3000 milliseconds, right? So let's run this. Let's wait, and you can already see that it's taken much longer. And yeah, as you can see, the time taken now is 3000, and that is not good because we can just as easily run it in only 1000. So let's revert our code back to 1000 and let's check it out again just so that we know that it's still working. And yeah, now it's taking 1025. So async and await are really cool, but sometimes we don't need to run multiple things concurrently. But we still don't want to block the thread. For that, there is the withContext, and I'm going to show you how to use it right now. But first, let's copy the function example async await, because our withContext function will be really similar. So let's rename it to example withContext. Instead of the third one, the third 2 and 3, we're going to have result 1, 2 and 3. That's because async is returning the third on which we can await. However, withContext doesn't return the third, but it returns directly whatever is coming out from our calculate hard things, and in our case that is an integer. So let's rename them to result. Alright, and now let's change async to be withContext. And we need to specify the coroutine context explicitly for withContext, so let's just say dispatchers.default for now, and let's change every async to be withContext. Now we cannot await on our results, so let's delete await. And as you can probably tell, withContext is basically the same thing as when we were calling await after each and every async. It does the precisely same thing. And when we copy the name of this function and run it, you can see that it took 3000 milliseconds approximately. The core takeaway from these last two examples is that you should use async when you want to run multiple calculations or something else concurrently, so when you want to await for multiple things at once, and that will enable you to run these asyncs concurrently, which will save significant amount of time. However, when you have some one-off operations or some other operations which you just don't want to run concurrently, you should use withContext because it's simpler to write and it is designed for that, for waiting for the result immediately. Alright, and that's it for this tutorial. If you wanna get the code, go to the link in the video description, which is gonna take you to resocoder.com. If this video helped you to understand Kotlin's coroutines, give this video a like and also share it with others. Subscribe for more tutorials and also Android tutorials like this, and also hit the bell button so that you are actually notified about those videos. Leave a comment if you have any suggestions or anything else to say. Follow me on social media and see you in the next video.